Okay, hi, hello my dear students, how are you all? I hope that everybody is fine, and I, Ritika, am back bringing with me another amazing session for all my amazing students. Alright, so I welcome you all here at Unacademy, wherein we are here to ace our Term 2 examinations with Unacademy Plus. Now students, if you subscribe to Unacademy Plus, you will be getting a flat 10% off. Now how is that possible? I will be telling you, but for that you have to stay here. Okay, let's quickly begin our class. But before that, let's know a bit about me. So learners, I am Ritika, a chemistry educator on Unacademy. I have completed my engineering in electronics and communication and also been awarded grade A by Cambridge English ESOL. So that was about me. And now talking about the topic that we are going to learn today, we are going to study today. It's the very amazing and the very important topic of your Term 2 examinations, the gas laws. So it's our very first session for the gas laws, and if you are here, then you should be sharing this video maximum with your friends, with other students, so that they can also take the advantage of the session here. Okay. Now students, what you can do is you can follow the Unacademy Champions page channel on Telegram. And why to follow that? So students, what will happen is you will be getting regular updates of all the YouTube classes, of all the special classes, and one more thing, of all the ongoing offers and discounts on Unacademy. So for not to miss anything, you should be following this page, Unacademy Champions, to stay updated regularly. And also let us subscribe to this channel, and let's target 1000 subscribers. So my dear students, for this I would need your help. What you need to do is you need to share this video to maximum number of students, okay? And please subscribe and press the bell icon. So if you press the bell icon, you will be getting the notification before the class begins. So you don't want to miss the amazing lessons taken by the amazing educators here at Unacademy. Just you need to subscribe it. Okay? Alright. So study of the gas laws. Let's quickly start with this very amazing and very important chapter. Now, talking about the gaseous state. So what is gaseous state? It's a state of matter in which the interparticle attraction is weak and the interparticle space is large. Now, if I talk about the molecules of a gas, they will be somewhat like this. Okay, far away. Okay, now what is this interparticle attraction? What is this interparticle space? We will be learning in our upcoming slides. Okay, so we will be knowing about each definition and what is actually the meaning of attraction, interparticle space, etc. will be seen. So all the gases, they show a kind of uniform behavior under similar conditions of temperature and pressure, irrespective of their chemical nature or color or odor. So whatever the gases are there, what happens over there is all the gases, for example, if I go for oxygen, carbon dioxide, etc., etc., etc. So all the gases, they are showing the similar condition of temperature or pressure. Now, it doesn't depend what their nature is, what their color is, or what their odor is. Okay, the thing is they are showing same kind of behavior, same kind of nature. Now let's compare, the properties of solid, liquid, and gas. What is the thing that differentiates solids from liquids from gas? Let's see some of the properties. Okay, let's start with the properties. So we will be doing here solid, then liquid, and here gas. So the very first property is solid. They have got definite shape and volume. Okay, Talking about the liquids, they do not have any definite shape, so means no definite shape, but they have got definite volume. Okay, so they have got definite volume. Okay, we will be reaching up to kinetic theory of solid, liquid and gases there. We are going to do it in today's session. Now, talking about the gases, so they neither have shape nor volume. Okay, so that is our first difference. Okay, next is, if I talk about the molecules in the solids, they are closely packed. Talking about the molecules of liquid, they are comparatively loosely packed. Okay, so here we have loosely packed. And in the gas, the molecules are far apart from each other. Okay, the third is talking about the intermolecular space. So if I talk about the interparticle or intermolecular space, so it is the space between the molecules, right? Now if I take a case of solid, this intermolecular space will be very less, like minimum. Okay, in the case of liquids, the intermolecular space is comparatively greater than solids. So we have comparatively more than solids. And in the case of gases, the interparticle intermolecular space, it is maximum. Next, if I talk about the intermolecular force of attraction, so we will go for intermolecular . So in the case of solids, it is maximum. Now I will be showing you how is it maximum. Okay, in the case of liquids, it is less than solid, and in the case of gases, the intermolecular force, it is minimum. All right, next is their capacity to flow. So solids, they cannot flow. The case of liquid, they flow from a higher level to lower level. And in the case of gases, they can flow freely. Now we saw two words or two terms. First is intermolecular force of attraction, and the second one was the intermolecular space. Now what is it? See students, in the case of solid, if I show you the particles, how they are packed. In the case of solid, what happens? The particles are very tightly packed. Okay, so this is how the particles are packed in the case of solids. Okay, so what you can see over here is the intermolecular space, that is the space between the molecules over here, you can see. So that is very, very less. Okay, and what happens over here is the force, okay, the attractive force that the molecules exert on each other, like this is exerting on these both, this is exerting on all these. Okay, so that becomes maximum because the particles are very near to each other. In the case of liquids, what happened? The particles are arranged somewhat in this way. So not very near and not very far. So what happens because of this? The intermolecular space, it is comparatively more. Okay, so we can say that it is having some kind of interparticle space, and therefore the force of attraction, it will be slightly less than the solids. And in the case of gases, we are having the particles which are very far away. So the interparticle space is maximum and therefore the force which, let's say, this molecule can exert on this one or this one, it is very minimum, very less. Okay, so that is the difference between solid, liquid and gas. I hope that is very much clear. Now let's talk about behavior and characteristics of gases. Now, as you know, the gases, they are made up of molecules or particles which are in constant random motion. So they are continuously moving. And there is a theory known as kinetic theory. It helps us, or it explains us, the relationship between pressure, volume and temperature of the gas. Okay. Now, if I talk about the kinetic molecular theory, it explains the behavior of gas on the basis of some of the properties of gases. Now, what are those properties of gases? Let's study them one by one. So first is composition of gas. So the gases, they are made up of what? They are made up of tiny particles which are known as molecules, and these molecules are in constant random motion. Okay. Next, we're talking about their shape and size. So we just now saw sorry. So we just now saw that the gases, they neither have no fixed shape. So they neither have fixed shape nor volume. Okay. So what happens if I put gas into any container? It will take up the whole space of the container. Okay, and the movement, it will be restricted by the walls of container. Otherwise, the particles will be in a constant random motion. Next is gases, they exert pressure in all directions. So they exert pressure in all directions. Okay, so if I talk about the molecules of a gas, okay, if I keep it in a container, what will happen? Because of their continuous random motion, they will keep colliding with each other or with the walls of the container. Okay, and because of this collision, what will happen? The pressure will be exerted. Okay, now next is gases, they are highly compressible. Okay, so students, as you know, the gases, they have got a large interparticle space between the molecules, right? And because of this, they are highly compressible. So what's the reason? Large interparticle space. Correct? Okay. Next is the gases, they are highly expansible. Now, if I talk about the gases, they increase in volume. So gases, they increase in volume when we decrease the pressure or increase the temperature. Okay, so the gases, they are expanding, they are expansible. Next property is they have got low density. Okay, why? Because if I talk about the number of molecules in a unit, that is comparatively very less when we take the case of liquid and solid. So that is why their density is very low. And the last is they diffuse easily. Now students, for example, if you spray, or if you have a room spray, if you spray it, what happens? The fragrance of that spray, it spreads into room very quickly. Now why does this happen? Now see, let's take the case. These are the gas particles, right? Okay. Now what will happen is, if I have sprayed the room spray or perfume, okay, what will happen? The interparticle space of the gases, it is very very large. So what will happen? These molecules, it will get along, they will mix, okay, and that is known as diffusion. That is how easily, or I can say it is the process of gradual mixing of two substances because of molecular motion. Okay, so that is the reason why the fragrance, it spreads very quickly into the room. Okay. Alright, so students, a very important information for all the students of grade 9 to 12 of ICSE board. So as you know, Unacademy is continuously rolling out the amazing offers for its students. So this one is an example or a type of offer for all the students. So ICSE board students of grade 9 to 12, you're having an amazing offer which is going to end on 31st of January. So you don't have much time. Now what is the offer is, if you buy a plus subscription for 12 months and above, okay, now you will be getting two things. First is the 10% discount that you know very well, and the second one is you are going to get 3-month K-12 subscription absolutely free of cost. But this offer, it is valid only for first 500 subscribers. So for that, what you need to do is you just need to hurry up. Okay, please hurry up. Please be among the first 500 subscriber and get the extra 3-month subscription with extra 10% discount absolutely free. Okay, so please hurry up and also share this news with all your friends. Okay, another amazing information for you all. Okay, so it's 21st of January today, right? Now students, it's just 2 days. Now we have Unacademy Prodigy. So it is back with exciting prizes and rewards. So you can enroll now for free. You will be winning amazing prizes. Okay, very exciting prizes and rewards and scholarships we are having over here. The test is scheduled for January 23rd, 2022 from 12 p.m. to 1 p.m. The link is provided. You can check it out. And if not, you can even join the Telegram channel. The whole detailed information about Unacademy Prodigy is provided to you. Okay, so please don't forget to enroll yourself and to take this test to win amazing prizes. Okay, now let's talk about the relationship of temperature, pressure and volume. Now, if I talk about the kinetic model, what does it say? It says that the molecules of any substance are in a constant random motion. And the energy which is possessed by the motion, it is kinetic energy. So since the molecules, they are in random motion, so that means they are having what? They are having kinetic energy. Now the average kinetic energy of any particle, it is directly proportional to the absolute temperature. Which means if the temperature is increasing, the kinetic energy increases. The temperature is decreasing, the kinetic energy decreases. Alright. Now, so what's the case here? If temperature increases, what does it mean? The molecular motion, it increases. If the temperature decreases, the molecular motion also decreases, right? So it means they are directly proportional. Now if we go according to this particular thing, what should be the temperature? Okay, what should be the molecular motion when temperature is 0? So according to this concept, if the temperature is 0, the molecular motion, it should cease or it should stop, right? If it is increasing, molecular motion is increasing. If temperature is decreasing, the molecular motion is decreasing. So if temperature is 0, the molecular motion, it should stop. Okay. Now students, this is just a theoretical concept. Okay, now this is the fact, or this is the theory which is applied on a temperature scale which is known as Kelvin scale. Now I'm sure all of you must have heard about absolute zero. So what is this absolute zero? The temperature at which the molecular motion, it completely stops, just according to theoretical concept. On the Kelvin scale, it is known as absolute zero. So if I talk about absolute zero, which is also known as 0 Kelvin, it is equal to minus 273 degrees Celsius. So if I talk about temperature lower than this, it is not possible. I hope that is very much clear. Okay. So if I go for the absolute zero, it becomes minus 273 degrees Celsius. Okay. Now, let's take an example. If I'm having a vessel, let's say this is a vessel that I'm having, and if I enclose a gas in it, so these are the molecules. Now what will happen? These gas molecules, what will they do? They will exert uniform pressure in all directions, which means it will be giving the, or it will be exerting the uniform pressure on the walls of the container. Okay, now why is the pressure being exerted? Because these molecules, they collide with each other, okay, and they collide with the walls of the container. Okay, now there are many, many molecules or many particles, okay, which are colliding with each other and with the walls of container. So therefore, there's a good amount of force which is acting on the wall. Okay, so the force exerted on unit area of wall of a vessel, it is equal to what? It is equal to pressure of the gas. Okay, now how to define pressure? The force which is exerted on a unit area of the wall of vessel, it is defined as the pressure of the gas. Okay, now talking about the gas laws. The behavior of a gas under known conditions of pressure, volume and temperature is described by laws which are known as gas laws. Now how is the gas behaving? Let's say if I increase the temperature to a certain amount, then what will happen, or what will be the effect to the volume or to say pressure? Okay, so that is governed by the gas laws. So there are the standard variable for gas laws, that is the behavior of a gas. It can be identified using the three standard variables, which is the volume, temperature and pressure. Okay, now if I talk about any given mass of gas, a change in one or more than one variable, that is if I change pressure, or volume or temperature, the other variables, they will also have a change in them. Now let's see how, or we will be seeing what is the relationship between temperature, pressure and volume. But before that, we will be seeing what is meant by temperature, pressure and volume. Now first of all, let's talk about volume, denoted by V. So what is volume? It is the space occupied by a gas. Okay, so the space occupied by a gas, it is equal to the volume of the container. Okay, so that will be the volume. Now if I talk about the units, so in SI system we measure the volume in meter cube. We can also have other units such as centimeter cube, millimeter cube, milliliter, liter, etc., etc. Now here 1 meter cube, it is equal to 1000 dm cube equals to 1000 liter. Okay, so these are the relations you should be remembering. So 1 liter, it is equal to 1000 ml, and it is equal to 1000 centimeter cube. Okay, now let's talk about pressure. Now what is pressure? It is the force that is exerted by gas per unit area on the walls of its container. So the pressure that a gas it is exerting on the walls of a container that it is enclosed in, it is equal to the pressure. Now talking about the units over here, we are having SI unit, which is Pascal. Okay. Now other units can be atmosphere. Then we have centimeter. So that is centimeter Hg, centimeter in mercury. We have mmHg. Then we can have torr, which is named after the scientist Torricelli. Now here 1 atmosphere, it is equal to 76 centimeter of Hg, or 760 mm of Hg. So I hope that is very much clear. Next is the temperature. Now what is meant by temperature? So it is the degree of hotness of a gas. Okay. Now most commonly used scale for temperature we are using is centigrade scale, which is also known as Celsius scale. Okay. And then we also use the Kelvin scale. Okay. Now how to convert Kelvin? So Kelvin, it is equal to degree Celsius plus 273. So just add 273 to degree Celsius to get the temperature in Kelvin. Hope that is very much clear. Now let us move on to the next thing, which is Boyle's law. Now that is a very important topic of our today's session. Now what happened? There was a scientist named Robert Boyle. Now what did he do? He studied the relationship between pressure and volume of a gas. Okay. So what happened here was, okay, yeah, so he studied the relationship between pressure and volume. Okay, so what did he notice? That at a constant temperature, which means temperature we are not disturbing, we are keeping it constant, the volume of any fixed mass of gas, okay, of a dry gas, it decreased by half when the pressure on it was double. So when we are making the pressure double, the volume, it is decreasing, or it is becoming the half. Okay, and it became 4 times its original volume when the pressure was decreased to 1/4. So we will be seeing what is meant by Boyle's law by a statement. So Boyle's law, it stated that volume of a given mass of dry gas is inversely proportional to its pressure. Now the very important word, at constant temperature. Okay, so in this case the temperature, it should be kept constant. Now what did Boyle find? Okay, so we had, first of all, the situations were we had constant temperature. Okay, that was first situation. Now what did he saw? He took a fixed amount of dry gas. Okay, So let's talk about pressure and the effect on volume. So the volume of any fixed mass of dry gas, it decreased by half. So it became half when the pressure was doubled. Okay, and it became 4 times of its original volume when the pressure was decreased to 1/4. So it became 4 times. Okay, so that was the thing that he saw, and this was given by the Boyle's law, that the temperature constant being temperature being constant, the volume of any given mass of gas, it is inversely proportional to the pressure. Now let's have a mathematical expression. So we are taking, suppose a gas occupies volume V1 at pressure P1. Okay, so what we will be writing, V1, it is inversely proportional to P1, or we can write V1 it equals to Kp1. When we remove proportionality sign, we need to have an equal to plus constant. So we can write by transferring that P1 V1 equals to K equals to constant. So that is our first case. Now next is, if V2 is the volume at pressure P2, next important thing is temperature being same. So what will be the thing here? V2 is inversely proportional to P2, and we will write V2 equals to K upon P2. Okay, and then we can write P2 V2 equals to K, or it is equals to constant. So from this first and this second equation, what we can write, P1 V1 equals to P2 V2 equals to K at, what's the condition? We need to have constant temperature. So that is our Boyle's law. So what is the another statement that we can give for Boyle's law? The product of volume and pressure of a given mass of a dry gas at constant temperature is constant. Okay, so this is important. The temperature, it should be maintained constant. I hope that is very much clear. Now let's see the graphical interpretation or verification of Boyle's law. So we have the graphical verification of Boyle's law. Now what does Boyle's law states? That if the temperature it is maintained at constant, what we will have, the volume it will be inversely proportional to the pressure of the gas. Now what's the condition over here? The temperature it should be maintained constant. Okay, so no change in the temperature, the volume of any mass or any mass of a gas, of a dry gas, it would be inversely proportional to the pressure applied. Now if I talk about the graphical verification, let's have it. So yeah, this is our O, then we have x-axis, here y, will be plotting pressure here, and the volume it will be on y-axis. Yep. Okay, so if I go for the graph of Boyle's law, let's have it this way. So it will be 1, 2, 3. Okay, so this is the basic graph that we will be getting over here, a straight line. Okay, so this is variation of volume against 1 by pressure. Okay, this is 1 by pressure, I'm sorry. Okay, so that is the graphical verification of Boyle's law. I hope that is very much clear. Okay. All right, so yeah. Okay, now we will be moving on to some of the examples of Boyle's law, which is again a very important thing. Okay, first of all, let's talk about significance. Now, in our real life, where do we find the Boyle's law? Now, according to Boyle's law, what happens as the pressure is increasing? So as the pressure increases, what happens? The volume, it decreases. Volume decreases means what? The gas, it becomes dense. Okay, so we can also say at constant temperature, density, it is directly proportional to pressure. So if pressure increases, the density will also increase. Now talking about, when we move to higher altitudes, okay, when we move to mountains, what happens? The, atmospheric pressure, it is very low. Okay, so that means what? Density will be less. So air is less dense. And because air is less dense, what will happen? We will be having less amount of oxygen which is available for breathing. And that is the reason why do we need to carry oxygen cylinders, or mountaineers especially, they need oxygen cylinders to be carried with them. Okay, so I hope that is clear. Now let us move on to another important thing. Okay, so this is what we did. Okay, just a minute. Yeah. Okay, so talking about the reasons, so what will happen is as we are moving, up, the altitude is increasing. What happens over there is the air is less dense. So how we can give it in a chart? High altitude, less density. Okay, so air is less dense, which means less oxygen available, and because of this, what happens? We need oxygen cylinders. Hope that is very much clear. Now let us move on to some of the numericals of Boyle's law. Okay, now first question, it says any gas, there is a gas, it occupies 800 centimeter cube under 760 mmHg pressure. Now we have to find out at what pressure the volume would be equal to 380 centimeter cube, and the condition which is given to us is temperature is constant, right? So now students, what are the values given to us? First is volume 1, it is 800 centimeter cube. Volume 2 is given 380 centimeter cube. P1, it is given as 760 mm of Hg, and P2 we have to find out. Now, since temperature is constant, so what we can say according to Boyle's law, P1 V1 equals to P2 V2. Now, if we substitute our value, 760 into 800 is equal to P2. So we don't know P2 into 380. Now, if we transfer it, okay, so the volume will be, this is 2 times So the volume will be 1600 mm Hg. Okay. So I hope that is very much clear. The volume will be 1600 mm Hg. Now let's move on to the second question. Okay, so the second question asks that there is a gas which occupies 600 centimeter cube and the pressure over here is 700 mm of Hg. Now we have to find at what pressure the volume of gas will be reduced by 20% of its original volume. And what the condition is given? T is constant. So if T is constant, we can apply Boyle's law to this question. Now see, we have been told that the volume of gas should be reduced to 20% of its original volume. So let's solve it. Okay. So 20% of the original volume. So original volume is 600. So 20% of 600, it is equals to 20 on. So it's equal to 120 centimeter cube. So what is the new volume? It is reduced. So our new volume would be 600 minus 120, which is equal to 480 centimeter cube. Now what are values that we have? We have P1, which is equal to 700 mm of Hg. Then we have got V1, which is equal to 600 centimeter cube. We have got V2, which is equal to 480 centimeter cube, and we have to find out the pressure. Okay, so if we substitute the values P1 V1 equals to P2 V2 at temperature constant, we will be getting 700 into 600 equals to P2 into 480. And if we solve it, now this is what we will be getting. So P2 will be equal to 875 mm of Hg. Okay, so I hope that is very much clear to everyone. Okay, so let's move on to our next question. Okay, just a minute. Yeah. Alright, so we are having a next question which asks that okay, so a capacity of one cylinder it is, so capacity of one cylinder it is 4 dm cube. Okay, and the other one, so we have cylinder A, that is 4 dm cube, and the other one is 1 dm cube. The pressure of the first cylinder it is 560 mm Hg, and that in second is 1000 mm Hg. Okay, both of these cylinders, they are having carbon dioxide. They are connected together by a tube fitted with a tap. What will be the final pressure in either cylinder on opening tap if temperature is constant? So temperature is constant first of all. Now what are the things that we have been told? See, volume of first cylinder it is 4 dm cube and of second is 1 dm cube. The pressure of first is 560 and the second one is 1000. Now these both are connected. They both are having carbon dioxide and they are connected by a tube. Okay, now if we open the tap, what will be the final pressure in each of the cylinder. Now we will be talking about each one. Okay, so here solution. Let's talk about first cylinder. Now what is given to us? If I go for the total capacity, if I open the tap, the volume, it will be added. So what will be the added? So total volume will be 4 plus 1, that is 5 Tm cube. Now for first cylinder, what will be the condition? What is P1? 560. Okay, P1 V1 equals to P2 V2. This is the formula I am applying. Now P1 it is 560 and V1 it is 4. Okay, and what is P2? We have to find out because it is the pressure of the cylinder, not the second one, right? When we open the tap. So P2 we have to find out, and what is the volume? When we mix, it is 5. So if I solve it, 560 into 4 upon 5. So that will be 448 mm of Hg. Now this is for the first cylinder. Talking about second cylinder, the volume it is given to us 1 dm cube. Pressure it is given to us 1000 mm of Hg. Now P dash we have to find out, and V2 again it is 5. So applying the formula P1 V1 equals to P2 V2, what do we have? We have 1000 into 1, this equals to P2 into 5. So transferring and getting the values, I have the pressure 200 mm of Hg. Okay, so now for the final pressure, what I need to do is final pressure it will be equal to what? 448 plus 200, which is equal to 648 mm of Hg. I hope that is very much clear, this particular question. Alright, so let's quickly revise what are the different things that we have learned today. So we learned about the gases, okay. We started with the gases. We saw some of the properties. So we will be having a quick revision of all the things that we have learned in our today's class. Okay, so I hope first of all these numericals are very much clear to you. And now we will be moving on to the So let's see what is the thing that separates solid, liquid and gases. So there are certain properties which are different in solid, liquid and gas. So talking about solid, they have got a definite shape and volume. Their molecules are very closely packed. And since their molecules are closely packed, they have a minimum intermolecular or interparticle space. And because of this intermolecular space being minimum, their intermolecular force of attraction is very high and they cannot flow. Next is liquid. They have not any, they haven't got any definite shape, but they have definite volume. The particles are comparatively loosely packed, okay, and the intermolecular space is a bit more than that of solids. And because of that, the intermolecular force of attraction is also a bit less than solid, and they can flow from higher level to lower level. But talking about our gases, what is the condition over here? They haven't got either fixed shape or volume. Their molecules are very far apart, which means their intermolecular space is maximum. And because they are having a good interparticle space, their intermolecular force of attraction, it is very low, and they can flow freely in all directions. Okay. Next is the behavior and characteristics of gases. So there is certain things. So composition of gas. So the molecules of gas, they are in constant random motion. They haven't got any fixed shape or volume. They can exert pressure in all the directions. They are highly compressible, okay, because of large interparticle space. Next is they are highly expansible. So gases, they increase in volume with decrease in pressure or increase in temperature. They have low density and they can diffuse easily, which means they can mix easily. Okay. All right. Now talking about the relationship between temperature, volume and pressure. Okay. So we have a Kelvin scale which is based on theoretical concept. Okay. So if temperature increases, the molecular motion it increases, and similarly the temperature decreases, it leads to the decrement in molecular motion. So according to this, if the temperature is 0, the molecular motion it should stop. So we had a Kelvin scale which was based on this concept, which was a purely theoretical concept. So what is absolute zero on Kelvin scale? It is a temperature at which molecular motion it stops completely, okay, and it is known as absolute zero or 0 Kelvin. Now, the gas laws, so very first law that we are going to study is Boyle's law, but before that let's study about volume, temperature and pressure. So what is volume? Volume is the space which is occupied by a gas, the SI unit being meter cube. The other units we have is centimeter cube, liter, milliliter, etc. Then pressure. So pressure, it is the force which is exerted by gas per unit area on the walls of its container. The SI unit is Pascal. The other units are atmosphere, torr, centimeter of mercury or millimeter of mercury. And the temperature, it is the degree of hotness of any gas. The scale are centigrade or Celsius, or we have Kelvin scale. Now talking about Boyle's law. So what does Boyle's law state? It says that the volume of given mass of any dry gas, it is inversely proportional to the pressure at constant temperature. So we are having a gas which is, let's say, occupying volume V1 at pressure P1. Okay, so this is the condition. V1 is inversely proportional to P1. So removing this sign, we get a constant. Okay, so this is the first equation. Then if there's volume V2 which is occupied at pressure P2, temperature is same. So this is the equation that we get. And if we combine both the equations, we get this, which is known as Boyle's equation. Okay, then we did some of the examples and I hope they were very much clear. Okay, now students, a very important information, Unacademy subscription features. So as you know, your term 2 examinations are very soon going to start, right? So it's very important to start your preparations very seriously, to take your revision seriously. Now for that, Unacademy is rolling up continuously new features, that is the batch courses, the special classes, etc. Now what is Unacademy subscription and why is it helpful to you? So first is you can learn from the comfort of your home. You will be having unlimited access to all your courses and you will be taught by top educators of India at one platform. Not just the classes, students, you will be having regular doubt clearing session, you will be having answer writing session and your syllabus will be covered. Also, you will be under the mentorship of your educators and you will be receiving all the study material in your PDF format. We will be having regular tests also to understand how much are we able to learn to understand certain concepts and things. So you can use my code, that is RITIKACLIVE, to receive daily practice session, weekly mock tests, live quizzes, MCQs and subjective test series. Now where to use this code, let us see. First of all, you can choose the Unacademy Plus subscription for first of all any duration that you are comfortable with. So it is available for 6 months, 9, 12, 18, 24, 36, 48, 42, whatever. Now you will be using my educator code down at the referral or referral code option. So you will be using Ritika, CLIVE. So this is my educator code and you will be getting an instant 10% discount. Now talking about the batch courses. So as I told you, we are continuously rolling up the new batch courses, crash courses, and these crash courses are in both the languages, that is Hindi and English. So a similar batch course, a crash course, it is started from 17th of January, which is Udan, an all subject batch in Hindi, and Mavericks, which is all subject batch in English. Now students, if you subscribe for grade 10, you will be getting the subscription of grade 11 and 12 absolutely free. So this is again a very good and very amazing opportunity. Do not fail to avail it. Now, what is Unacademy free special class? So students, these classes are absolutely free of cost. All you need to do is download the Unacademy Learner app to watch this. So here we are having lifetime interaction. Okay, we are having chats, emojis, so the interaction really becomes very interesting. We have quizzes, we have polls, we have leaderboards so that you can compete with your friends, and also you can ask questions using the question tab. Now, how to watch my special class? You have to download the Unacademy Learner app. Just open the app and click on Get Started. If you enter your mobile number and OTP, you will be signing up using your email ID. You will just put in all the information. And in your case, students, the goal will be class 6th to 12th. Okay, you'll be selecting your board and class and also the language that you prefer to learn in. Now students, in the description of this video, there will be a special class link. So that is the link of my special class. You will click on it, and if you click on notify me, you will be notified 10 minutes before the class is going to begin. And you can use my code. So this is my code to unlock that special class for free of cost. Okay. So what are the things that we have learned today? We learned about the properties of gases, the standard variables, and the Boyle's law. I hope that you might have understood everything. So students, please download Unacademy Learner app. You can get it on Google Play Store or App Store and try all these features for free of cost by using the Educator code. Let us meet in our next class, in which we will be learning a lot more of things. And till then, keep studying, keep learning. All the very best for your examination preparation.